Okay, so we talked about 5S. Oh, and by the way, please put your cell phones on silent. So I've already forgot to put mine on once today during the meeting. So let's take a look. What do you think of when I say visual workplace? Don't say it's a workplace that's visual. All right. Here, you see the flow going? See the flow?
Color coding or signals?
Color coding. Well, most people, and I'm one of them. Some people can read directions and follow precisely. Now, I can if I have to, but I don't like to. All right. But you give somebody, I mean, how do we teach children to do something, or how do they play? They get colored blocks, you know. And you guys remember the little game where you had the box with the stars and the blocks and a crescent moon, and you had to get them in the right holes in order to get all your blocks in the box? You remember that? That's the same principle. All right? Simple, stupid. All right? Easy as you can make it. So, it's a system we use it to organize, and that's why it works with 5S. Okay? We talked about 5S. And visual workplace kind of, if you have 5S, you're going to have a visual workplace. All right? Shadow boxing, your tools on the wall, is a visual workplace. Does that make sense? Can't have one without the other. All right? Because you can't have a visual workplace without having stuff set in order. Does that make sense? All right? And you can't set stuff in order without some system. I mean, I guess you could have a wall of tools with pegboards and tiny little numbers and a lookup list, and that would not be a visual workplace. You know, you could like put the tools up there and say that tool number 1 goes here, and then you'd have to pull out a list and look that up. But that doesn't make a lot of sense. You just do the shadow box. It's a visual thing. And so what it is made to do, well, let me think about this. How many of you have, this is the big thing, and I've done this before, is your current operator status, your production status of the line up on a big screen in front of the production line, right? How many of you have that? You've got that? It's not always taken on, but at least most of the supervisors can pull up something and see what their current production totals are. But that's part of a visual workplace. And basically, if you don't understand what I'm saying, it's where you're doing, all right? You have a goal to meet in a shift, right? And where you're at in that goal is shown on a board where everybody can see. And it's usually displayed. Anybody heard of the word OEE, or Operational Equipment Effectiveness? Okay? Basically, all that means is if you have a line, there's a theoretical runtime for your line, an average, and that versus, you know, how many parts per hour. I'm supposed to make 100 parts per hour. You know, and then you have a little computer software, and you're halfway into the hour, and you've made 50 parts out of 100. Guess what? You got it 100%. All right. If you've only made 35, you're dropping down, and they show that in real time, so people, because naturally, if you show that up on a screen, people see that. I've got to do better, right? Got to do better. I've got to work faster. All right. So it gives people a goal to reach. So, visual workplace. Can you imagine going to work and not knowing how to do your job? If you did it correctly, if you were ahead or behind. All right. Well, part of a visual workplace is signboards. They indicate what belongs where and in what quantities. Okay. So that's something to think about, especially for you guys on your project. All right. Status board, we just talked about that. Remember I covered the big computer screen or big TV. Basically, it's a big TV up there, and whether you're on or off production. Okay. real-time representation for like a signboard. And signboards don't have to be, you know, a big production. I've seen signboards that on break, every break, the supervisor goes and calculates where everybody's at. It's a simple equation, and they go there, and when they come back from break, they've got it in big letters spelled out in markers or chalk that says, we're at a certain percentage of our daily goal, all right? And that we need to, you know, they'll put it red marker if you're behind, green marker if you're ahead, yellow marker if you're a little bit below. That's the way that goes. Another part of visual controls, mark pathways, aisles, or storage sites, right? The yellow line, the forklift, that's where the forklift goes, all right? Your dowel, I've been out there. Don't walk where the forklift goes, you'll get in trouble, right? All right, so there is a path for people, there's a path for forklifts. Mark on walls, columns, racks to indicate locations or maximum heights of storage. Like, well, if you've got a, let's just say a tooling, and it has a place, and you've got it labeled to store it over in storage location E2. And usually a lot of these signs, first of all, they have to be visible. How many people have seen, they'll run a string of cable across a wall up high, right? And on that cable, they'll put some little signs that say a location on them. And a lot of times they'll just say like storage location E2 or whatever. And there'll be a list where you're supposed to put stuff, right? But if you don't know where that stuff goes and you can't, the forklift driver has to be able to drive up and go, oh, E2, and pull in there and drop it off, right? All right, he'll get issued a changeover, and they'll have a document that says, go get the changeover tooling from storage location E2 and bring it up. And that's what he'll do. And when he's done, he'll put it back. That works until somebody doesn't put it back in the right place. But lights. All right. How many of these have these in your factory? All right. You have those, and basically it's a light for the operator. All right. And when there's a problem, they flip the light on. Just like at Walmart, when you're ready to check out, you look for light that's on. Watch out. You don't go to somebody standing at a checkout counting out their drawer and their light's not on. You don't go up there and try to check out, do you? You wait to see their lights on. Okay? So, there's simply a little switch here, and it's basically, these are set up that a lot of times maintenance personnel has a big view of the whole work floor, and it's usually done in cells, and most of them are the same. So they want to know what's going on. All they have to do is look across there, and when they see a red light, they know to go there. That makes sense? It's visual. They don't wait for somebody to call them on the radio. All right? Most of the time, you get the light on, and then you get called on the radio. So. But it's a good indicator, because if you're driving down a length of equipment and you're supposed to go over here and you're not really sure who the operator is, and you're riding your little bicycle down the rows, and you're looking and you see a red light, and you go, oh, I got to go over here. All right, so it's a clue for where the problem is. So, color coding. That's basically what we're talking about. If you want to color code dies, all right, you're just talking about color coding dies. All right. Well, you know, what tools do I need for the blue dye? Well, I need all the tools that are painted blue. Make sense? Pretty simple. Work instructions, part of visual factory. Here are some examples of some graphs, like you would have these up on the screen and display them to the workers in real time. I don't know what that costs. Defective items displayed. All right, that's another biggie. How many defects are you running? Because remember, Lean's a measure of quality. If you're not making good parts, you're making scrap, right? Error prevention boards. You know, master quality and production boards indicate a history of production, and those you see a lot in factories. If you walk in, you see what the current goal is for the month. All right, who achieved the highest record? What line produced the most? And winner, chicken dinner. They all get a steak dinner, right? So you set a goal. You keep track of it. You put it on a scoreboard. And where do you put it? You put it where everybody walks through. On the way to the break room or the bathroom. That's where it goes. Here we go. Maps. Location and process flow map to track activities. Photos showing correct procedures or assembly. All right, that's a biggie. All right. Here's my widget. Would you rather me hand you this and say make me a widget? Would you rather hand me this and say make me a widget? There you go. That's it. That's it in a nutshell. All right. Checklist. Another part of visual displays. Oil and greasing, operator setup procedures, cleaning procedures, improvement data, and progress charts. So, most of you, depending on your project, part of your project for your special projects, right? You're going to want to think about checklists. Okay? You're going to, like with you, when you do a changeover in on your area, you know, they're going to go through there and they're going to check certain parts. Is it set up correctly? Right? Part of that's quality. If they do a changeover and it's not correct, they have to stop and redo it. Or, you know, you put part A over part B and you got to take part A back off. You know, that doesn't accomplish. So you're going to think of checklists. All right. Now, not only do checklists help, they also have a place for signature at the bottom, right? So they also add accountability. Who didn't, if you checked off a box and it was not correct, okay, and then come back and you say, well, why didn't you do this? So, with that in mind, I will show you a video. And I don't know how well it'll record, but I'm not going to use any names, but I had a termite inspection schedule. Okay? Everybody know what you do when you have an inspection for termites. They walk around your house, and they've got a checklist, and they look for little burrows and dirt dogs down at the bottom of the house to indicate you've got termites. So, I was irritated because I have a surveillance system at my house. And the background story of this was I had an appointment scheduled for 2. They called the day before, short notice. I said, all right, I'll take off work and I'll come down there. So I show up at 2, and there's a little note in the door that said, sorry, we missed you. We've done your outside inspection, rescheduled for an inside. Well, of course, I'm immediately on the phone. Get him back, and he says, and he's late, and this is a big deal. And he does the inside inspection, and it's great, no problem. But at the same time, I'm thinking, I wonder how good a job he did on the outside. So I have a video. Just say they redid it. What I am not going to do is put this on YouTube because I don't want to get anybody in trouble. I'm not even going to use the name, but I'm going to put his face on YouTube. So we'll have to turn that off. And let's see what happens here. All right. And I'm going to go ahead and hang out because it Okay. So we watched the video and we saw that what happens when you just check boxes, you don't do your job, right? Because guess what? Somebody could be checking on you. Right? That was the whole point. Right? It's not just to go along checking boxes when you have these checklists. Although it happens quite a bit. And that's an important point to bring up when you're collecting your data. Some of your data is going to come from existing checklists. If you notice how, if sometimes on one shift or one operator, you know, everything is always perfect, you should begin to suspect that something is not perfect. All right? That's the key giveaway. If everything is always perfect, if there's no problems, or, you know, I mean, of course you have an inspection and then you're supposed to check all the boxes, but, you know, if you have production tallies or everybody's dead on, you know, they didn't have any problems, their uptime was great, or every downtime they had was, you know, I've got 4 hours to maintenance, but maintenance doesn't have a record of that downtime, that kind of deal. So be aware that that goes on quite a bit. So you can't always trust checklists. All right. Now, my previous job before this was we would automate the data collection process. We would take the human factor out. So basically, the machine would record its own production data, its own downtime data. And I didn't really like it. I mean, the system wouldn't make it to do that, but they would even have an operator log into the machine, right? So now all the production tallies are, a supervisor can go in there and pull up a spreadsheet and see how much work they did. Okay, in real time. Well, within a few minutes, but you could actually see, you know, when it stopped for how long. And we gave them a choice where they had to enter a code. So, checklists are not always accurate. Don't just check them. That's my take on that. You know, workplace boundaries, we're talking forklifts, it's kind of summing it up. Visual documentation. Let me ask you something. If I needed to do a job, okay, and I had to have all these tools, and I had a piece of paper printed out that I laid down, and it said, before I begin this job and stop production, I'd have every little picture on this paper filled up with a tool, right? You get where I'm going? Like, so I have a job. I need a hammer and a screwdriver before I stop production, downtime. So, and I'm going to do a blue changeover. Whatever the tool is, let's just say, you just say, have a little piece of paper out here, and I'm not an artist, but here's a hammer, and here's a screwdriver. It's a flathead. And so, before the operator turns off the machine, of course, here's their changeover sheet, fill it up with tools, right? And it could be a Allen wrench here, and it could be a socket here with a wrench. I'm not very good at that. It looks like a arm and stick person, but you get my drift, okay? So it's always a good idea to have something visual when you're trying to accomplish something, because that's how most people can identify with stuff. Instead of just telling them to give them a checklist and say, get 1 3/4 wrench, get you know, get a 5/16 Allen wrench, you know, just give them a list of tools. It's a lot easier if you actually have it laid out. Get a hammer. Marking of areas. Where do I put my tools? Basically, visual information and instructions. Visual control, monitoring signals for machines, lines, processes. Record of problems is a big one. All data must be current or is useless. Okay, must be correct too. Reduce everybody's frustrations because they don't run around cussing looking for a tool or what they need. All right, there's nothing. How many people in here have done a job and spent more time looking for the tool to do the job than actually performing the job? Most everybody in here should raise their hand. I got a loose screw and I spend more time looking for the screwdriver than, you know, it's 5 seconds. All right. I've I've even seen places, you know, they'll put them on cords and tie them up where they got to pull the cord down, right? Improves quality and productivity, reduces frustration, promotes waste elimination, safety. Now, why would this promote safety?
Just use the right tool for the job. Yeah.
Right tool for the job. And guess what? They're not laying in the floor to trip over because they're supposed to be on the wall. Right? Increase worker understanding. It's much easier to train a worker when you hand him a picture of the tool. I mean, we did this right here, but we can take a picture of the tool and say, go find this tool that looks like this picture and put it on there before you start doing a changeover, right? Make space. Nothing makes space more than pegboard. I didn't show you a picture of my shop, but basically, I think I figured out 1,500 square feet of pegboard in there, so I use it all. Supports continuous improvement. Work instructions, technical procedures. Now, same thing with everything else we talk about. If you're going to do it, then do it. Don't just halfway do it and stop. All right, so that's all that says. So, basically, you can walk into an area and you can look around and understand what's going on by just looking around, right? Is there a problem? There is one there because there's a red light. There's one there because there's a red light. Oh, I'm running at 98% efficiency. It's right there on the board. That kind of deal, right? So when you start thinking of these situations and how you would do 5S and how you would do a visual workplace, you can't think like a person that's worked there 20 years. You have to think like the person that walked in off the street, right? In fact, if you want to understand it accurately and how well it works, you don't need to look at the people that's been doing the same job for 20 years. You need to find the new guy and have him go through the documentation and see how well he does it. Does that make sense? Because guess what? The guy that's been there for 20 years, he's not going to be there much longer. He's going to retire, so you want to keep this going. I'm not going to go with that far. We're going to start on our project here in just a second. I want to kind of clarify. I've got a little PowerPoint here I'm going to bring out. Now, this PowerPoint is, I put a lot of this stuff online, you know, in Google Drive. So, on Google Drive, there's a little folder called Extra Stuff. And I have one that's what is OEE. And I made it, so if you guys want it. But if anybody's ever heard that term, OEE, and you didn't really understand what was going on, I'm going to show you an easy way to understand it. Hopefully it's easy. There is a math equation that goes along with it. Yeah, this is just 23 slides. I'm going to go through it pretty quick. Okay. So, along with the visual workplace, we want to measure this data. The most current way we do that is we use the term OEE. And there's 3 factors that make it up, and there's calculations for each factor. All right. Most of this is all automated in the software, but you don't have to have the software to do it. You can just run it through the math equation if you wanted to. All right. Typically, these are installed in data collection systems, and it's real time. That's the big deal about it. So you hear the data collection. It's a real-time data collection. And when we put them in the systems, they were accessed. Basically, corporate could go look at any of their plants and pull up runtime data on any line within the plant. Does that make sense? So, overall equipment effectiveness, all right? Made up of 3 parts: speed, uptime, and quality. Sometimes you hear it called operation equipment effectiveness. Basically, it's a company's theoretical output versus their actual output is all this is. And you're going to ask, well, that sounds complicated. Well, I have a machine that's designed to run 100 parts a minute. Because I bought it, and the max speed on that machine is 100 widgets a minute. All right? Well, guess what? That machine will never make 100 widgets a minute. Because the theoretical maximum of a machine is basically when all the things are brand new and everything is in tolerance, and that some engineer, when they designed the machine, pushed it as fast as they could, and they made 100 parts a minute. All right? Did they make 100 good parts? Hopefully. But they sold it to the company, and the company puts it in, and it's been in for a couple of years. Everything's getting a little slow, tolerances. It won't make 100 parts a minute. All right? So if you buy a palletizer, and it's supposed to palletize 100 boxes a minute, you're not going to get it palletizing 100 boxes. So we have our theoretical output versus the actual. Now, this theoretical output, there's different ways to look at it. We can look at it from machine. We can look at it from process line. So it doesn't necessarily have to be a machine. I put these in poultry, and they were cone counters, right? And so there's no machine, okay? There is simply a line with a cone, and then on the cone goes the chicken, and as they come through there, everybody cuts off their little part, right? So there's really no machine. There's just a conveyor that moves chicken. So the machine is the people, and so they know how many chickens they can process a minute, right? And then this would measure what they actually processed. Okay. Now sometimes where this theoretical number is, what I'm supposed to be making, what I can theoretically make, is either that depends on the situation in the company. Sometimes it's way too high, and sometimes it's way too low. Okay, but you will never get theoretical maximum limit. First of all, there's breakdowns and maintenance. Well, maintenance doesn't have, but there's breakdowns. So, you know, you get a breakdown, something jams, you get defective input. I mean, it's never going to happen. So what we're trying to do is base that we can, you know, we want to get typically what everybody tries to shoot for, somewhere above 80%. If you can get 80% of your theoretical max, you're doing great. Okay, so availability, performance, and quality. Availability, the amount of time the process machine was ready to produce versus the scheduled time. All right. Basically, is the machine available? All right. That means, is it running? Okay. Doesn't mean if it's producing. That means somebody's got it on and it's ready to run. Versus scheduled time. And that means the scheduled time. Like I have a break. I mean, I have a shift and it's 8 hours. Do I make production for 8 hours? No. I got a 30-minute lunch and 2 15-minute breaks. I make production for 7 hours. That's my scheduled time. Does that make sense? So, if it's running but it's not producing, then that's part of it. That's the availability. It's operating time divided by planned production time. So basically, this is your running time, your uptime, versus the time that you're supposed to be making widgets. All right? Takes in the downtime. Here's where the downtime comes in. And here it goes. Scheduled downtime or breaks do not count against availability because that gives you a false number. So basically, what we're taking here is breakdowns. You got it? And the breakdowns could be machine or people or somebody that needs stuff. Performance. The speed of the actual process versus the set point speed. Okay? That's how many widgets you're making a minute. If you're supposed to be making 100 widgets a minute, but you're only making 90, then you're running below your set point speed. Now, back to the beginning, this is not the theoretical maximum run. That comes in no, sorry. Yeah, this is the ideal cycle time, your theoretical max, which is as fast as you can go, versus the actual time. How many parts per minute you make. Quality. Now we add the quality aspect. Because guess what? Bad widgets don't count. Alright? And so, look at these math equations. And this is just ideal cycle time. Well, let's say I'm supposed to make, I could theoretically make 100 widgets a minute divided by, well, let's just say I can make 100 widgets in an hour. So I would divide the operating time, that would be 1 hour, divided by the total pieces, which only make 98. Does that make sense? I'm not getting into math. That's the math, okay? So the quality is the good pieces divided by the total pieces, right? All right. And so basically, once you get these three equations done, all right, and then go back here. Operating time divided by planned time, I mean that's 8 hours, divided by the actual running time of the shift. You were supposed to run 7 hours and you had a breakdown and only run 6.5. You divide those numbers together. You do the same with this. Here, this is pretty simple. Good pieces divided by the total pieces you produced. Then you would multiply them all together, and it gives you a percentage. And that's what, if anybody's ever seen them, they'll see the OEE box. All right? And that's your theoretical, that's the real-time data that most of the places display. They'll show a graph bar. All right? So, one thing that people can do, because when you get one of these systems in, you're starting to monitor this, is they'll fool it. Okay? And they can inflate that. There's two ways you can inflate it. You can lower your theoretical maximum below what you could make, and then you'll get a good number. They will run it excessively fast. Okay? And the quality, even though they're making bad ones and it counts against them, it overinflates the number because that quality aspect has a little bit lower value. It causes the number to overinflate. Scheduled downtime does not account against availability. All right? So if you're doing all these factors, and especially if it's automated, like most of these systems, they run 365 days a year. And so if it's an automated system, you have to put in there Christmas, Easter, shutdown. All right? Because this would basically calculate it per minute, per hour, per day, per month, per year. So you have to go in there on these calculations and take all that out. Because you can't just go in there and say, well, I wonder what my OEE is for the year divided by 365. It would be bad. All right? You can't do that. You have to start counting holidays and weekends and all that. And you must take out the breaks. All right. So, I like this one. What do I do while waiting for my toast to pop up? I get the butter, clean up the kitchen a little bit, and I stare at the toaster the rest of my time. So, here is some actual data. Notice we have how many birds they were processed in an 8-hour shift. The running time, here they run for 7 hours. Here, this might have been a 10-hour shift, I don't know. But the breaks are taken out of that running time. When we put in one of these data collection systems, we would actually record every second the line was stopped. Okay? When they hit an e-stop, it would start recording time. Log it as stopped. We would monitor the speed of the line through all the shifts. We looked at this. We were supposed to run 41 birds per minute, right? And we'll see that, I'm not going to go through here, it's too small to see, but at night, they were running pretty good. These right here would actually be like breaks where they stopped. And then come first shift, they slowed the line down, right? And so you can record that data, and you can go, why in the first shift running what they're supposed to be, right? Right? That's a speed set point, right? The supervisor has control of it. And one thing you'll notice here because that should be an even number, right? But it looks like here somebody cranked it up a little bit. Over here they cranked it up. So, and I don't know what happened here, but they cranked it up quite a bit there. So they turned it up to 50 birds a minute. So they're not getting consistent flow. All right. So that gives you an idea of that. So the line doesn't start running exactly at shift change or break. Small stops throughout the day for just a few seconds, right? All right. We all agree if we have a line or we're working at a bank, people go to the bathroom, right? So there's small stops, all right? So average runtime out of a shift is 7 hours out of 7.5 hours, all right? Now here's the part that that really gets people is, why do I need OEE in my plan? I like that one. Our quality and manufacturing award fell apart. But if you start doing the math, lost time per day times 3 shifts, 1.5 hours. And that's just with e-stops and little breakdowns. That doesn't seem like a lot. 3 shifts, right? 20, you know. So at 1.5 hours per day, we're going to lose 369 widgets. 6 days, we lose about 200,000. 1 year, we lose almost 1 million. And if you do, so if every widget was 3 cents a widget, right? And you did the math, in a year, you're losing $35,000 on a line, just by those little 5 and 10 second stops. Does that make sense? And most of this data collected, there's like multiple lines in the plan, right? So if all your lines are losing $35,000, it shows you where this money's going. And it's nothing to be blamed or pinned on. It's just, why are we hitting the e-stop? All right? Why are we jamming? All right? People see these little, well, let me give you an example. I worked at a facility that was optimizing, it would make hardwood flooring, and they would have an optimizer that would optimize how wide a cut to make out of a big plank, because you got 2 1/4 and 3 1/4 hardwood flooring. So if there's a knot or something bad, a little computer would control it, and it would tell it where to cut, so we could cut a straight edge and get rid of the knots. Well, there was about a 3/4 second delay in the processing of this board. So for 3/4 second, this board sat there. Okay, that doesn't seem like a lot, right? But you got to remember, they're running 41 boards per minute. Now, in order to keep up with production, this system it was a bottleneck. It wasn't keeping up with production. And they would have to bring in a cut crew earlier than regular production. So they were paying people overtime to come in an hour earlier than the start of the normal plant in order to have enough boards cut for the rest of the plant to process into hardwood flooring, right? By eliminating that 3/4 second cut on there, they actually started producing so much extra wood that they were taking the cut crews and making them help sweep, because they would fill up the inventory racks and just stop, and then they would move them around to help elsewhere. Right? They didn't send them home. I'd say that. That's not what this is about, eliminating jobs. But they would actually gain production time on a bottleneck. So a 3/4 in a high-speed production line, what I'm saying is 3/4 second is a lifetime. You get me? Because you start adding that up per widget, that's a lot of time. Okay. Are there any questions so far? Comments? We're going to move on to our, yeah.
Just one quick question. I know in a lot of facilities, the older people tend to watch in the first shift. How do you do any type of calculations for that in your OEE?
No, it should be the same for all shifts. But you're saying that they just don't produce as much.
Correct.
You're right, they don't. And it's been that way from the end of time. It's just the way it is. But I do know what you're talking about. There's really nothing you can do about it. Just one of those deals. I mean, I guess you could say they do worse, but I guess I'm trying to understand. You're just saying old people are slow?
Basic, kinda. Well, I mean, and you shouldn't expect someone who's worked at a plant for 40 years to run as fast as
Oh, you
some
should.
kid off the street.
No, trust me. I know I'm getting old. There's really nothing you can do about it. But you're talking about adjust the output. I mean, you can adjust your theoretical max if you say that. Well, I guess you could say that first shift has old people on it, so we're going to slow down their goal by 2 widgets a minute, and then it would compensate. That makes sense?
Yeah.
I thought it would probably be the opposite, because somebody that's been there a long time, or are we just talking about old people in general?
I don't know how old people were.
No, I'm just saying, like in our plant, the people that's been there the longest, they are the older people, but those smoke the guys coming in because they.
Yeah, you got a point. I guess it really depends on the process.
Right.
I would say, well, I'll rephrase. Let me backtrack. What you're talking about is very labor-intensive work. I have seen that. Okay, but we're talking, you know, people are taking boards and they're throwing them, right, and it's hard on your back, right? Well, labor-intensive is a little different than experienced operators. Does that make? I'm trying to make sense.
Right,
here.
right. I see what you're saying. Yeah.
All right. He was. I don't know. Is that what you're talking about? Labor-intensive?
Yeah, I mean, in most cases, yes.
Yeah. So there's a difference between an experienced operator that can keep a machine going
Right.
at optimal speed and tolerance, and in that case, it wouldn't matter because the experience is helping them. But you have to admit, and I will admit to myself, you know, when I was electrician, I used to pick up motors and carry around, or I'd get a 10-foot thing of conduit, 1-inch conduit, and I'd plug it across there, and I'd head right up there. I don't do that no more because I like my back. All right, that's kind of why I quit, because my back started giving me a problem. But anyway, so there is that factor. It depends on the labor intensity. But in labor intensive situations, shouldn't really the supervisors be the experienced hands to guide the younger guys and keep them on track? So that's
We'll take a younger guy who walks in the door, say 21, and he's worked there 5 years. He should be, I would think if he's in the same position, he ought to be plenty experienced enough to do his one, whatever it is he has to do.
I think it just goes back to individual plants, but anyway, I want to shut up now. I'm going to stop this recording. We can carry on after I stop the recording. Do you want to carry this discussion?